All right, we're live, everybody. Hello, how's everyone doing? Just gonna go over everything we've talked about the last couple of weeks. I'll start with fifth grade and then move my way up to eighth and seventh to an extent. But with fifth grade, you guys have a rock project. Hi, everybody. I see everyone's talking about wows. I know what it is, but we're gonna be covering a little bit about everything that content related. Man, we're almost 2 weeks, 3 weeks ish. 3 weeks of content, 3, 4 weeks. I forgot. It's less than four, but hopefully we'll get this done. If you have questions, again, just comment section on my YouTube channel. Just let me know. All right. With that being said, quickly classification of rocks. Three types of rocks: igneous, metamorphic, sedimentary. Igneous rocks you tend to find near volcanoes. The only way you can make igneous rock is by melting it, like literally melting it to liquid molten rock slash magma slash lava, then cooling it off. Whether it be slowly or quickly, depending on which rock, depending on your project as well. Some rocks cool quickly, some don't. Don't take a long time. If they cool quickly, you get obsidian. If it goes slowly, you get stuff like granite and stuff as rocks and stuff. Usually it's just shiny glass. Gives it away if it was cool quickly or not. That's how we make glass. You just cool molten rock quickly. For glass like mirrors and stuff, you cook sand at a really high temperature and then instantly freeze it or cool it. And yeah, rock cycle. That just tells you how each rock turns into one another. For example, igneous rock. In order to make a sedimentary rock, igneous or metamorphic, whichever the two, needs to start being broken down either by water or by wind, ice, any natural occurrence, gravity can break things. Animals can break rocks. Over time, you have all these rocks breaking up into little pieces, and eventually you have amalgamation of all these rocks that are just piled together. And these piled rocks tend to be cemented naturally. And sixth grade next year, sixth and seventh grade, you guys will do this next year when we talk about we'll talk about the rock cycle in the beginning of the school year. It's one of the first things we talk about. So how do you make metamorphic rock? Unlike igneous rock, in order to make igneous rock, you either take sediment or metamorphic or pack igneous rock again and just melt it to liquidy substance. Metamorphic rock, you just heat it. You heat it and add pressure to it for a long, long time. Like in order to make marble. Oh, Thor. Sorry, Thor's crying. He wants to be up here, but I can't because I have food. Um, Basically, in order to make metamorphic rock, you need to don't bitey. Need to basically add heat and pressure, but for a long, long time. Like marble takes like almost an eternity. It feels like it takes like hundreds of thousands of years in order to actually keep that pressure and keep it heated for a long time. Usually, metamorphic rocks can be found in places that are or former plate boundaries. That's how you usually get it. It's okay. Usually, that's where you find it. Like that's why the what's called Mediterranean is full of marble like structures, is because marble is readily available everywhere. Even today, it's still readily available everywhere. But that's how you make metamorphic rock. Uh, Last thing, really, what else for the rock cycle? Just know that everything could go into each other. If we were in class, I would actually have you make the rock cycle over so long series of time. No bites. Um, but yeah, that just know some buildings, certain types of rocks are better than the others. For example, if you have limestone in an area that you get a lot of acid rain, that limestone is going to start getting weak over a few decades to a century. Like some buildings, yeah, their color does not look the same. Like at U of I, there's an old math building that's made of limestone. It looks disgusting now. Like if you literally dig with I forgot what chemical, I think hydrochloric acid. For the first layer, you can see it's actually yellow. It's actually yellow. The brick is yellow, but the building looks black because of the acid. It's like almost like how the Statue of Liberty used to be bronze because it was made of copper, but over time oxidation ruined it and made it green, and that's what we associated now, the Statue of Liberty green. But yeah, just know that that's some properties. Rocks are used for everything: construction, everyday things. Your digital devices are made of metals, rocks, and stuff. Just melted and warmed over. Your project will be due tomorrow, and after that, we will cover fossils. And I think fossils might be the second to last thing we'll do, and then I think after that, the last thing we'll do will be either weather or physics. One or two, but that's how we'll end fifth grade. Sixth grade, on the other hand, oh boy, it sounds a lot familiar, doesn't it? Yeah, because we did stuff like this in chapter 1 and in chapter 3. Basically, solutions, compounds, and mixtures. Basically, what you will be, yeah, he plays a lot. Anywho, what you guys will be doing is a little bit more in depth. For example, what's the difference between saturation and supersaturation? Saturation means that it's already reached the maximum that the solute and solvents. Solute is what goes in solvent. Or he wants to go upstairs, but no one's upstairs. That's the problem. So I keep him down here, so he at least has someone to play with. Basically, the solute goes to solvent. If it overflows, you can say, it's like, for example, let's say there's a bunch of kids inside a ball pit. Obviously, you're going to be saturated. But if there's way more kids than balls in the ball pit, obviously you're super saturated. That means it's spilling out. That's why you shouldn't put, you might have seen YouTube videos or movies or TV shows where they suddenly just pour a bunch of coffee or Nesquik into a glass of milk, and it's already dripping out powder. I'm like, oh. That's supersaturation. Saturation is just when it reaches the limit. And then you have concentrate. Diluted means there's not a lot. Like, for example, if I put a teaspoon of sugar in the ocean, the whole water is not going to suddenly be sugary. It's going to be really low. Same thing. In order to, for example, something saturated, you want to dilute it. Basically, get as much of the solvent out. So you usually add or take, depends. But usually you add. For example, when you cook and you want to dilute a flavor, you add something else so that it expands. Concentrated, you just has an equal. It's kind of equal. You can taste it. Like, for example, if you add enough Kool-Aid, you'll actually taste the flavor and not just be. I don't know. Sorry for the lags, but hey, that's everything. Just remember, compound. Usually, natural compounds are actually made by elements. Once you have those compounds mixing, that's where you get the mixture. All right. Let's see. Is there anything else I got to talk about? No, that's it. Next chapter, I believe, which you'll do next Tuesday, will be acids and bases. That one's kind of fun. I wish we could be in class because I would love to do acids and bases and be in the classroom. So much fun, acids and bases. All right, and I'm going to end the day with some 7th, 8th grade science. So you guys are going over cells. Congratulations. Welcome to the intro cells. To Friday, you'll go more into the organelles. Now remember, organelle is what is made of a cell. Like the organs of a cell, organelle. It's in the name. Also, one thing I want to talk about was cell theory, because this is something I alluded to earlier. Cell theory, and to an extent, 5th grade and 6th grade should know this. Basically, there's 3 laws that state of whatever. Jeez, people are constantly emailing me. Strap it. Keep going. Basically, cell theory is that there's 3 laws. First, also everything living thing is made of cells. Cells are the basic unit of any organic life, and cells can only make other cells. How's a cell born? Well, the only way you can make it is from another cell. Oh, I forgot about that. I'll put it on a link or something. I'll mention next live stream. I haven't looked at everything. Sorry, I've been catching up on grading, so I can't answer that. Soldo. Another thing is Robert Hooke. You want to know his name because he's the one who helped, the microscope to actually stare at and study cells. Another important thing. There's a bunch of other people, but that name's more specific. But that's cell theory. For cells themselves, human cells, remember, we're going to work with humans. Though there's 2 types of cells. Technically, there's prokaryotes and eukaryotes. The only big difference is prokaryotes don't have a nucleus. Their DNA is just scrambled everywhere, all over the cell, while eukaryotes have a central nucleus where all the DNA is stored. Like there is a central brain, while prokaryotes don't. Prokaryotes are mostly bacteria, while eukaryotes are more the cells you have in your tissue. Human tissue, speaking of tissue, that's what cells make. Tissues make organs make organ systems make organisms. And then there's more biology stuff. We remember back from September before we went to what's it called, Fermilab. With a cell, know that the cell, the main part of the cell on the outside that protects the cell membrane, due to, you could say, acids and bases. This is something that sort of covered in sixth grade, but basically it allows stuff to phase through the cell membrane in and out depending on like is it compatible or not. Cytoplasm is the main gooey material inside that tends to hold everything together, allows movement within the cell. Um, Organelles, I already mentioned, DNA is your written code. It's all the material inside your global body that allows the study and to function. Now, not all the DNA for each cell is used. Only like I think like 0.5 or 1%, depending on which cell it is. Not all of it's used. For example, your DNA, like the reason why you can clone a person out of any cell in your body is because it has all the DNA for the whole body. But you only need a sort of section. For example, the DNA from your pinky to, I don't know, make a nail in your pinky exists in your eye, but you don't need it for your eye. Instead, you need the ones that are specific for the eye to be turned on. So it's like sort of like, well, here's a whole book, but this area only needs this chapter to work. That's how DNA works. With that being said, you'll have, I think you have right now an assessment. You'll have part 2 or the actual organelle stuff and a little bit of meiosis next week. But yeah, that's everything. Man, you guys had a blast talking about your games in the comment section. Well, hope you guys enjoyed that. I'm going to head off. It was just a short, quick refresher of all the stuff we've talked. I'll see if I can do another live. I really want Google to work, but whatever. But we'll see what we can do. All right. Take care, guys, and I'll see you next time. Ciao.